So this is lesson 2.7, and we'll just say A because there'll be a couple of those. And this is called More Applications, More Story Problems in Elementary Algebra. And again, we're going to do it pretty much like we did the last one, kind of stick with a couple different topics. I think it's just 3 this time: consecutive integers, interest, and mixture problems, and triangles. So I guess there's 4 of them, 4 different types here. So let's stick with consecutive integers first here at the beginning. A consecutive integer is just a counting number that follows one right after another. I guess a counting number and negative numbers. So 3 and 4 would be consecutive. 8 and 9, just one right after the other. When you get to negatives, it's like negative 3, negative 4, negative 6, negative 7, you just count down. But the key thing when you're dealing with negative numbers is it's easy to look at this one and say the 4 is bigger than the 3. When you got negative numbers, you assume that the 4 is bigger than the 3, but it isn't. Because when you're looking at a number line, which one's closer to 0? Okay, when you're looking at negative numbers, you're looking at which number is closest to the 0. So you have 1, 2, there's negative 3, there's negative 4. Negative 3 is closer to 0, so it's the bigger. On the right-hand side, it's what's furthest from 0, and that's bigger. So another way to look at it is which number on a number line is furthest to the right, and that will always be the biggest number. So negative 3 is bigger than negative 4, and negative 6 is bigger than negative 7. So when you're talking consecutive integers, and if they ask which one's bigger, and it's a negative, you know how to find that now. All right. If we're looking for odd integers, consecutive odd integers, so what would be the next odd integer after 3? It would be 5. The next odd integer, or even integer after 2, well, it would be 4. All right, so this is a key thing. How far away is 3 from 5? It's 2, right? So if we didn't know the first number, and we didn't know the second number, the first number is x, the second number would be x plus what? How would we get to the next one? X plus 2. If we didn't know that this one was 2, we'd call it x, and what would this one be? How would we get there? We'd take whatever value this one was and add 2. Notice, consecutive odd integers and consecutive even integers are labeled the same way. So if I have 2 consecutive odd integers, one of them is going to be x, and the next one's going to be x plus 2, and the next one would be x plus 4. So if this one was 7, this one would be 7 plus 2 is 9, this one would be 7 plus 4 is 11. So I have 3 consecutive odd integers. Same thing with even integers. If one of them's x, the next one's going to be x plus 2, the next one's going to be x plus 4. A lot of students want to write x plus 1, but that doesn't give you the next odd integer. Let's say that my odd integer is 11, the next one is 13, the next one is 15, because I add 2 and I add 4 to our original one there. Okay, there's always between each number, there's a distance of 2. That's why there's a 2 here. There's always between these two a distance of 2. Okay? If I'm talking even numbers, and I'm still talking x plus 2, and my first one is 6, what's my next one? Distance of 2. What's my next one? Distance of 2. So both odd numbers and even numbers are going to give you x plus 2, x plus 2. Okay? So let's go ahead and look at a few of these. Start with example 1 here. It says the sum of 2 consecutive odd integers is 28. 2 consecutive odd integers, you just go ahead and just write it like that. And it says their sum is 28. There's the first one, there's the second one. Add my x's. Subtract 2. Divide by 2. X equals 13. So if I have 13 for my first one, my second one is going to be 13 plus 2, which is 15. Okay, and that's pretty much what there is to the integer section. Now let's jump to interest. Now there's a formula for interest, and we're going to use this pretty regularly. It's a pretty common formula. I equals RP. Okay, I stands for interest. R stands for rate. So like the interest rate on a loan might be 4%. Okay, that's where the rate comes from. And P stands for the principal. Meaning, the amount, let's say that you are investing money. Okay, if you invested $1,000, $1,000 is the principal. That's how much you started with, or you invested, or you borrowed. The interest rate would be how much money you're making off of or paying on that $1,000. And the interest is the dollars that you make or pay according to that interest rate. So let's go ahead and try a few of these. Example 2. Let's suppose that we invest a certain amount of money in an account that earns 8% interest. All right, so my interest rate, percent always means rate, is, they said 8%. That's my rate. At the same time, you invest $2,000 more than that in an account that pays 9%. So how much did we invest? We don't know. So I'm going to call it P for principal. That's how much we invested. So that's the amount invested. And that's our principal. That's how much we started with. And it made 8% interest. At the same time, you invest $2,000 more than that. So you also invested $2,000 more than your initial. And we'll just put other amount invested. Okay, so you invested P, and then you turned around and put P plus 2,000, 2,000 more. And what was the interest rate you did for that? It says 9%. Okay, so we have 9% rate of this amount invested, and we have 8% rate on that amount invested. So we just took two chunks of money and invested them. One made 9%, one makes 8%. If the interest from both accounts was $690, how much was invested? Okay, in each account. So what we've got is we've got this amount plus this amount. When we added the amount of money we made at the end of the year, it was $600. Let's get this working. $690. So if I took I equals RP for this one, and I equals RP for this one, and got two answers, added them up, I'd get $690. All right, so let's go ahead and write that as a problem here. So we've got our rate times our principal for this one here, using this formula, interest. This is the amount of money we made when we take our rate times our principal. Okay, so we've got 8% of P, and then we took our second amount at 9% and multiplied that by 2,000 plus P. And when we took that amount and added them both together, we got $690. Okay, so does that make sense? The amount we invested at P, the amount we invested P at 8%, we multiply those because it says rate times P, the interest times the principal, will give us how much money we made. So that's that. This one was 2,000 more than what we invested up here, so 2,000 plus P would be our other chunk that we invested at 9%. And it said when we added the interest together, we got $690. So how much is invested in each account? So what we're looking for is P, how much we invested here and how much we invested here. P and P plus 2,000. All right, so we had mentioned this in an earlier video. You never work with percentages. You always have to change them to decimals before you do anything. So let's go ahead and see if I can move a bunch of this out of the way. And I'm going to put, so I'm going to go ahead and write this as decimal. So you always move it over 2 to the left when you take off the decimal, or when you put on a decimal point. So it was here and we had to move it over 2, so that's why it's 0.09. Okay, so I'm going to get rid of everything except this bottom equation here. Okay, so I just slid everything up. Alright, so let's go ahead and distribute this 0.09 times 2,000, and we get 180, and then 0.09 times P here. Okay, add those two together. We get 0.17P plus 180 equals 690. And we subtract 180 from both sides. And we get 0.17P equals 510 from here. And then we divide by 0.17, divide by 0.17. That goes away, and our P is 510 divided by 0.17, so our P is 3,000. That's how much we invested the first time. And remember, we had two amounts. We had an amount we invested there, and then we invested another bunch of money. That was 2,000 plus P. So P is 3,000, and 2,000 plus P gives us 5,000. So we invested $3,000 at 8% and $5,000 at, 9%. And that's the answer that I'm looking for there. Okay? So in this next video, we'll get into mixture problems and triangles.